The year 2004. It was the day just after Christmas. A day that was witness to one of the world's worst natural disasters. An earthquake in the Indonesian islands had triggered giant waves which destroyed hundreds of thousands of lives and millions of dollars of property all along its path. The worst affected were the people on the east coasts of Sri Lanka and India. Countries lying over 5,000 kilometers away from the center of the undersea seismic activity. The world woke up to the rude shock of the power of the tsunami. This disaster brought people across nations together in an attempt to set up a tsunami warning system to prevent future tragedies, recognizing the imperative to put in place an early warning system for the mitigation of these oceanogenic disasters that cause severe threats to nearly 400 million of our population that live in the coastal belt, with devastation of life and property, and further driven by the national calamity due to the Indian Ocean tsunami of December 26, 2004. The Ministry of Earth Sciences has taken up the responsibility of establishing the National Tsunami Early Warning System. The warning system has been established by MOES as the nodal ministry at a cost of 125 crore rupees in collaboration with the Department of Science and Technology, DST, Department of Space, DOS, and the Council of Scientific and Industrial Research, CSIR. INCOIS, the Indian National Centre for Ocean Information Services at Hyderabad, has long been involved for years in ocean observations, information and advisory services, and it was only natural that it was chosen as the Centre for the Tsunami Early Warning System. A state-of-the-art early warning centre is established at INCOIS with all the necessary computational and communication infrastructure that enables reception of real-time data from all the sensors, analysis of the data, generation and dissemination of tsunami advisories following a standard operating procedure. Seismic and sea level data are continuously monitored in the Early Warning Centre using a custom-built software application that generates alarms and alerts in the warning centre whenever a preset threshold is crossed. Tsunami-genic zones that threaten the Indian coast have been identified by considering the historical tsunamis, earthquakes, their magnitudes, and also by tsunami modeling. The east and west coasts of India and the island regions are likely to be affected by tsunamis generated mainly by subduction zone related earthquakes from the two potential source regions, namely the Andaman Nicobar Sumatra Island arc and the Makaran subduction zone north of the Arabian Sea. The Indian Tsunami Early Warning System comprises a real-time network of seismic stations, bottom pressure recorders and tide gauges to detect tsunami-generic earthquakes and to monitor tsunamis. The Early Warning Centre receives real-time seismic data from the National Seismic Network of the Indian Meteorological Department and other international seismic networks. The system detects all earthquake events of more than 6 in magnitude occurring in the Indian Ocean in less than 20 minutes of occurrence. BPRs installed in the deep ocean are the key sensors to confirm the triggering of a tsunami. The National Institute of Ocean Technology (NIOT) has installed 4 BPRs in the Bay of Bengal and 2 BPRs in the Arabian Sea. In addition, NIOT and the Survey of India (SOI) have installed 30 tide gauges to monitor the progress of tsunami waves. Integrated Coastal and Marine Area Management, or ICMAM, has customized and run the Tsunami N2 model for 5 historical earthquakes, and the predicted inundation areas are being overlaid on cadastral level maps of 1:5,000 scale. These community-level inundation maps are extremely useful for assessing the population and infrastructure at risk. They could be used for better land use planning, building of shelters, planning evacuation routes, etc. High-resolution coastal topographic data required for modeling is generated by the National Remote Sensing Agency, or NRSA, using ALTM and Cartosat data. INCOIS has also generated a large database of model scenarios for different earthquakes that are being used for operational tsunami early warning. Communication of real-time data for seismic stations, tide gauges and BPRs to the Early Warning Centre is very critical for the generating of timely tsunami warnings. A host of communication methods are employed for timely reception of data from the sensors as well as for the dissemination of alerts. Indian Space Research Organisation (ISRO) has made an end-to-end communication plan using INSAT. A high level of redundancy is being built into the communication system to avoid single-point failures. The National Early Warning Centre will generate and disseminate timely advisories to the control room of the Ministry of Home Affairs for further dissemination to the public. For the dissemination of alerts to MHA, a satellite-based virtual private network for disaster management support has been established. This network enables the Early Warning Centre to disseminate warnings to the MHA as well as to the State Emergency Operation Centres. In addition, messages will also be sent by phone, fax, SMS and emails to authorized officials. In case of confirmed warnings, the National Early Warning Centre is being equipped with necessary facilities to disseminate the advisories directly to the administrators. It took over 2 years to put the infrastructure together. Some of the best brains of the industry were involved. No cost was spared to bring in the latest of technology. And on September 12, 2007, its efficiency was tested. 1640 hours, Indian Standard Time. An underwater earthquake shook the islands of Indonesia. The magnitude was 8.4 on the Richter scale. The ocean showed all the signs of leading to a tsunami. The Andaman and Nicobar Islands that were nearest to the epicenter were put on alert initially. But after analyzing the real-time water level data from tide gauges and the BPRs, it was evident that only a minor tsunami was generated. Models at INCOIS indicated that the southern part of the country would experience a minor tsunami. These regions were then placed on alert. It takes just 3 hours for a tsunami wave to reach the shores of Chennai from Indonesia, and 3 hours later, the beaches of Chennai witnessed a tsunami. Only that this time, it was not dangerous. The tsunami had lost its force. This time, no lives were lost. But there was victory. The tsunami was real. The target was just as predicted. The whole tsunami early warning system was functioning as designed. There would be no surprises anymore. The tragedy of December 26, 2004 could well be a thing of the past. It had taken less than a few minutes for the people at Inkois to recognize the possibility of a disaster striking, and another few minutes to alert the respective authorities, leaving them with over 2 hours to take preventive action. Man may not be able to control the fury of nature, but he can definitely use his knowledge to prevent loss of lives. And that is exactly what we do at Inkois, a place where science, technology and people come together with just one purpose: to help save precious lives. Welcome to the Tsunami Early Warning Centre at Inkois.